Hello everyone, myself Sagar Ramesh Kute, working as Assistant Professor, Department of Physics, GMD College, Sindar, Nasik. Now, last lecture we will discuss module first. Now, in this lecture we will discuss module second. In module second, the topic is condition for large stimulated emission and population inversion. Now, first topic is condition for large stimulated emission. Lacing is a process which leads the emission of stimulated photon due to the transition of atom from the metastable state to the ground state after achieving population inversion. For the generation of laser, stimulated emission is essential. Stimulated emission has to be induced or stimulated, and it generated under special condition as started by the Einstein. When the population inversion excites between upper and lower level among atomic system, it is possible to realize amplified stimulated emission, and the stimulated emission has the same frequency and the phase of incident radiation. The absorption and spontaneous emission always occur together with stimulated emission, as we know that Einstein coefficient relation is A 21 upon B12 is equal to 8 pi h mu cube upon c cube. This will be the equation number first. Therefore, the ratio of stimulated transition to the spontaneous transition is R is equal to stimulated transition upon spontaneous transition. That is, R is equal to dN1 upon dt stimulated upon dN1 upon dt spontaneous is equal to B21 N2 rho mu upon A21 N2. R is equal to B21 upon A21 rho mu. But we know that rho mu is equal to 8 pi h mu cube upon c cube upon e raised to e2 minus e1 upon kt minus 1. Therefore, equation 2 become R is equal to B21 upon A21 into 8 pi h mu cube upon c cube upon e raised to e2 minus e1 upon kt minus 1. That is, from equation 2, R is equal to 1 upon 8 pi h mu cube upon c cube into 8 pi h mu cube upon c cube upon e raised to e2 minus e1 upon kt minus 1. R is equal to 1 upon e raised to e2 minus e1 upon kt minus 1. That is equation number 3. From equation 3 gives the ratio of stimulated transition to the spontaneous transition if both are equal. That is, R is equal to 1 by 2. At thermodynamic equilibrium, B12 is equal to B21, then R is equal to N2 upon N1, equation number 4, and N2 upon N1 is less than or equal to 1. The two equation, that is 3 and 4, that is this equation 3 and 4, are to be satisfied to make stimulated emission over him to the spontaneous emission. Now, this will be the derivation of condition for large stimulated emission. Now, next topic is population inversion. All the atoms of element have their own characteristic system of energy level. The difference of energy level in an atom is of the order 1 electron volt to 5 electron volt, and the certain number of atoms can occupy the certain energy level. The number of atoms per unit volume occupying the certain energy state are called as population. The population of N of the energy level E depend upon the temperature T is given by N is equal to N0 e raised to minus E upon kT, where K is Boltzmann constant, that is this K. In a material, atoms are distributed in different energy level and tends to achieve lowest possible energy level, which may or may not be in ground state. For all laser operation, the stimulated emission is essential required. For a high percentage of stimulated emission, the majority atom should be higher energy level than that of the lower energy level. For this artificial situation is created known as population inversion. The term population stands for the number of atoms in active medium occupying an energy state. Let N1 and N2 be the population of lower and higher energy level. The population ratio is equal to N1 upon N2 is equal to e raised to E2 minus E1 upon KT. As per the above equation, it has been seen that the thermal equilibrium there is more number of atoms in lower state than in the higher state, that is N1 is greater than N2. The ratio of stimulated to absorption transition is given by stimulated transition upon absorption transition is equal to B21 N2 U mu upon B12 N1 U mu is equal to N2 upon N1. Therefore, U mu be the energy density of radiation for frequency mu B21 and B12 are constant. If by some techniques the number of atoms in higher energy state E2 is made much larger than in the lower energy E1, the stimulated emission is promoted. Hence, non-equilibrium position is created artificially in which higher energy level population exceed largely than that of the population in the lower level. This state is known as population inversion. At this position, the population distribution level E1 and E2 is inverted. This condition of population inversion can be achieved only by applying negative temperature. Hence, the state population inversion is sometimes called negative temperature state. The negative temperature does not mean that we can reach down the temperature below 0 degree Kelvin. The state of population inversion is non-equilibrium state, and general practice this state is obtained at ordinary temperature. Now in this lecture we discuss population inversion and condition for large stimulated emission. Thank you so much.